A certain brand of automobile tire has a mean lifespan of 39,000 miles and a standard deviation of 2,150 miles. Assume the lifespans of the tires have a bell-shaped distribution. A. The lifespans of 3 randomly selected tires are 34,000 miles, 36,000 miles, and 31,000 miles. Find the z-score that corresponds to each lifespan. Well, in order to do this, we're going to need to know what the z-score formula is. And we'll remember that z is found by taking your data value and subtracting the mean from it and then dividing by the standard deviation. The other alternative formula when we're dealing with samples instead of populations would be x minus x bar over little s, or standard deviation. Now for this problem we need to know what the mean is, and the mean is 39,000 miles. And we also need to know what the standard deviation is, and the standard deviation in this case is 2,150 miles. So we'll go ahead and find the z-scores for all 3 of these values. We'll start. Alright, so the first one that we're going to deal with is going to be 34,000 miles. So z will be equal to 34,000 minus the mean, which is 39,000, and we will divide that by the standard deviation, which in this case is 2,150. And when we go ahead and punch that into the calculator and divide, we'll end up with negative 5,000 over 2,150, which is equal to a negative 2.3255, and that goes on, and we'll go ahead and round that to 2 decimal places and get negative 2.33. So then we're going to do the next one, which will be 36,000 miles. So to find the z-score for that one, it'll be z is equal to the data value of 36,000. We will subtract the mean of 39,000 from that, and then we will divide that by the standard deviation of 2,150. And that will be equal to negative 1.3953, and that will keep going, and we'll round that to a negative 1.40. Then for the last one, we're looking at a value of 31,000 miles, so the z-score will be equal to that data value of 31,000. We will subtract from that the mean of 39,000, and then we'll go ahead and divide that by the standard deviation of 2,150, and that will be equal to negative 3.7209, and that goes on, and so we'll round that to 2 decimal places, negative 3.72. So these will be the 3 z-scores that we were asked to find in this particular problem. The next part of the problem asks if, according to the z-scores, would the lifespans of any of these tires be considered unusual. And by the empirical rule, we note that anything beyond 2 standard deviations from the mean would be considered unusual. And in this particular instance, I'm going to have this value and this value, which will both be beyond 2 standard deviations from the mean. So yes, there would be some values in here that would be considered unusual. Alright, part B asks or states the lifespans of 3 randomly selected tires are 34,700 miles, 43,300 miles, and 39,000 miles. Using the empirical rule, find a percentile that corresponds to each lifespan. The lifespan 34,700 miles corresponds to the nth or blank percentile, and then that asks the same thing for 43,300 miles and 39,000 miles. So in order to do this, we need to fully understand what the empirical rule means. So what does the empirical rule mean? Well, first off, let's look at a bell-shaped distribution, because that assumption was made at the beginning of the problem. And what we're going to do is look at the statements that go along with the empirical rule. We know from the empirical rule that 68% of our data values fall within one standard deviation from the mean. Notice that it's split up to 34% on the left and 34% on the right of the mean. Then we understand that 95% of the data falls within two standard deviations of the mean. Notice that this area right here would represent two standard deviations, and in this area is also two standard deviations. But we have to total the values here and here in order to get how much data is contained within those two standard deviations, and that would be 47.5% total. And that's going to be to the left of the mean, and it's also going to be to the right of the mean. And then finally, we'll look at this last piece, which says 99.7% of the data fall within three standard deviations, which means that we will add 2.35% to the 47.5%, and on this far side from here to the mean, that means that 49.85% of the data falls three standard deviations to the left of the mean, and the same thing is going to happen to the right of the mean. Now, in order to understand percentiles for this, what we need to do is start from the far left of the standard deviation, or far left of the bell-shaped distribution. So, as I've stated, 99.7% of the data values fall within three standard deviations. That means that outside of three standard deviations of the mean, we have 0.3%. In other words, on this far left, we'll have 0.15%. That's going to be beyond three standard deviations. And over here, we'll also have 0.15% that will be beyond three standard deviations. Now, let's look at our values, and then we'll take all of this and we'll understand it in just a moment. So the first one that we're going to discuss, the lifespan 34,700 miles, corresponds to which percentile? Well, we need to go ahead and understand where this falls. Now, if the mean for this problem is equal to 39,000 and the standard deviation is equal to 2,150 miles, we'll take that 34,700 and we will subtract it from the 39,000 to determine how many standard deviations we're dealing with. So when I subtract this value, I'm going to end up with 4,300. And 4,300 is equal to 2,150 times 2, or 2 standard deviations to the left of the mean. Now, where would that be exactly? Well, if this is the mean right here, 2 standard deviations to the left of the mean would be right here. Now, what would be the percentile? Well, we're going to have to start at 0, which is going to be down here on the far left, 0%, and then we're going to work our way up until we get to this value right here. Now, notice that there is 0.15% already in existence, which is going to represent everything that's beyond 3 standard deviations. And we're going to add to that 2.35% to get us to the 2 standard deviations below the mean. So 2.35% plus 0.15% is equal to 2.5%. So that means that the lifespan, 34,700 miles, which is right here, corresponds to the 2.5th percentile. So the lifespan of 43,300 miles, what does that correspond to as far as percentiles? Well, once again, let's go ahead and take the 43,300 miles and subtract that from my mean of 39,000. So the mean of 39,000 minus 43,300. Well, actually, I tell you what, let's go ahead and rewrite this as 43,300, and we're going to subtract from that the mean of 39,000, which is going to make more sense because I won't have a negative value. And when I subtract that value, I'll have 4,300 again. Once again, this represents 2 standard deviations to the right of the mean. Now, where does that fall in the diagram? Well, let's go ahead and look at the diagram. If we start on the far left, all the way down here, at basically the 0 percentile, and then we're going to move, this brings us to 3 standard deviations to the left of the mean, 2 standard deviations to the left, this is 1 standard deviation to the left, this is the mean, this is 1 standard deviation to the right, and this brings me to 1 standard deviation beyond that, or 2 standard deviations to the right of the mean. So what I need to do is understand that since I've started at 0% and I've gone all the way up to this value right here, what does that give me for percentile? Well, remember that I have 0.15% here, I have 2.35%, 13.5%, 34%, 34%, another 13.5%. And if I add all of those up, I will get to where I need to be. So when I add all of these up, this is going to yield 97.5%. So that's the 97.5th percentile, and that would be my answer right here. And then, of course, the lifespan, 39,000 miles, corresponds to the, well, 39,000 is the mean. That means that everything to the left of the mean, or 50%, so we're at the 50th percentile.